Okay, in this tutorial we're going to look at rational expressions. And basically what a rational expression is, rational is just talking about fractions. So we're really only looking at algebra dealing with fractions and how we simplify them. So let's just do a few examples. Let's say we had 32 ax squared y divided by 16 a squared x y cubed. Okay, so how we want to simplify these fractions is we simplify it as much as possible by looking at the numbers and the common letters that we can cancel out. So 32 and 16, I look for something common that could go into both of those, and 32 is double 16. So if I was to divide 16 into both of those, I would be left with a 2 on top. I've got an a and an a squared, so I can take at least one a out of both, so that would get rid of the top one and the bottom one, the exponent's gone. An x squared and an x, I can take at least one out, so that gets rid of the 2 on the top and it gets rid of the x on the bottom. And then a y and a y cubed, and I can take out one y. So I take out that one, and then that one would become a squared. So if I was to rewrite this simplified, I'm left with 2x, nothing else on top, divided by a y. So that'll be example 1. Let's do another example like that. Example 2. 35 x squared y z divided by 45 x y to the power of 4 z squared. Alright, so once again I want to look at what I could divide out of the numbers out front first. So what's common to 35 and 45? I could divide both of those by 5. And if I do that, I'm left with a 7 on top and a 9 on the bottom. Once again, for the x squared and the x, I can divide one x out of both, so that'll get rid of the squared and the x on the bottom. Y and y to the power of 4, I can take at least one y out, so that'll get rid of the y on the top, making that to the power of 3. And then I have a z and a z squared, so I can take out one z, getting rid of the squared on the bottom. And writing that answer, simplified, I'm left with 7x divided by 9y cubed z. Okay, let's do another one. So, example 3. Let's say I had x plus 1 to the power of 3 times x minus 2, all divided by x plus 1 times x minus 2 to the power of 4. Alright, so this time I don't have any numbers out front, but I have an x plus 1 on the top and bottom. I've got at least one that I can take out, so I'll take out at least one, leaving me with a squared on the top, and an x minus 2 and an x minus 2, I can take out at least one from the top and the bottom, leaving me with a 3 on that bottom one. So if I write that simplified, I get x plus 1 squared divided by x minus 2 to the power of 3 on the bottom. Let's do another one, and this time let's factorize a quadratic. So for example, let's have x squared plus 7x plus 12 divided by x squared minus x minus 12. So this time we're going to have to go back and remember how to factorize. So for the top one, what two numbers add to 7, and those same two numbers would multiply to 12? So that would be 3 and 4. So I'll factorize that into x plus 3, x plus 4. And then on the bottom, what adds to negative 1 and multiplies to negative 12? And that would be x minus 4 and x plus 3. Now I look there and I look what's common that I could divide out. Well, I have an x plus 3 and an x plus 3 that'll cancel out. But x plus 4 and x minus 4, even though there's an x and a 4, there's one's a plus and one's a minus, so those will not cancel out. So I'd be left with x plus 4 on the top and x minus 4 on the bottom. And I can't go any further than that. Let's do one more where we're factorizing a quadratic. So let's try 2x squared minus 3x minus 2 all divided by x squared minus 4. Alright, so for the top one, now we could use our graphics calculator and work backwards, but I'll do it in a few steps. So what adds to negative 3 and the same two numbers multiply to negative 4? So that would be negative 4 and positive 1. But remember, because of the 2 out front of that x squared, I can't jump right to that. So if you like, as a little side thing for factorizing this one before, I guess I write it on the top, finished. Let's use a different color. So this will become 2x squared, and we break it up into the two things we found. So that was minus 4x and plus 1x, which is just x. That makes that minus 3x. Then we look at what is common to the first two and what's common to the second two. So that would be 2x for the first one, leaving me with x minus 2. And for the second one, there's nothing I can really pull out, but I could say it's like pulling out a 1, because that doesn't do anything, and that's x minus 2. Meaning that these two here are common, so I can factorize that out, leaving me with x minus 2 in the first bracket, 2x plus 1 in the second one. So now if I go down here, I could jump right to x minus 2 over 2x plus 1, all divided by, now remember, x squared minus 4 is a difference of squares. So x is a square and 4 is also a square. It's 2 squared. So that gets factored into x plus 2, x minus 2. And I see an x minus 2 in both of them, so I'm going to cancel that out, leaving me with a final answer of 2x plus 1 on top divided by x plus 2 on the bottom. And I can't go any further than that. That would be finished. You may have noticed back on example 1, if I scroll back up there, that I had 1y divided out of y and a y cubed, and it should have been a y squared on the bottom. And notice how it's red, but then when I wrote the final line, I forgot to put the squared in. So let's add that right now. So it is a y squared on the bottom. So, if you want to try the next exercise starting with the rational expressions, give those a go. You can always refer back to this. And I guess you'll see how it goes. Hopefully it goes good.